Hello and welcome. In this video we are going to be creating an Identity Server 6 solution. This solution will have an Identity Server project, an API project, and it will also have a number of different applications that will get an access token from Identity Server and use that access token to send an authenticated request to our API. Now, before we get started, there's a couple of bits and pieces that we need to do. The first thing that we will do is generate a self-signed certificate. That self-signed certificate will be used for our SSL HTTPS connections between containers. For example, when the applications are calling Identity Server and also calling the API, we will do so over HTTPS, which means that we will need to generate a self-signed certificate for that SSL connection. So what you are going to want to do is make sure that you have OpenSSL installed on your machine. And what I'm going to do is come down to the terminal and I am going to run the OpenSSL command to generate a private key and a public certificate. You'll notice the subject is localhost, the common name localhost, and you'll also notice that we have subject alt names for localhost, API, Identity Server, single page application and web application. That means that we'll be able to use those host names in the browser rather than always having to use localhost, and I'll highlight why that's useful a little bit later on. So what you're going to want to do is run that command, and you can see there it generates a private key and it will ask us for a passphrase for the private key. I'm simply going to use a passphrase of password. However, feel free to use any other passphrase that you like. I will highlight wherever we use it, so if you do use a different one, you'll know where to replace it in configuration, etc. So now that we've generated our private key and public certificate, we're now going to want to export those into a single PFX file. So you can see there it takes in our certificate and our key, and it exports both of those out into a single localhost.pfx file. And we're giving it a name, creating an Identity Server 6 solution, because that is the name of this sample. You can see it's asking for the passphrase for our private key. So that was the passphrase that we entered just a moment ago, which I entered as just password. And you can see it's then asking for an export password for the PFX file. I'm once again going to use a password of just password. Feel free to use anything different that you like. And you can see there that has run successfully. And if we show all files, open the solution up, you can see we have our localhost public certificate. We have our localhost encrypted private key, and we also have our localhost.pfx file. Now what we're going to want to do is right click and open that PFX file in Explorer. And you can see here that we have our localhost.pfx file. If I double click to open it, you can see the certificate import wizard prompts me to import the certificate to my local machine. This means that I will be able to access those websites on my computer without the web browser complaining that the certificate for the SSL connection is invalid. So I'll import that PFX file into the current user store. Hit next again, and it's going to prompt me for the password for the PFX file. This is the second password that we entered earlier, which was just password. Hit next, and then we are going to manually select the Trusted Root Certification Authorities store. So make sure that certificate store is selected, hit next, hit finish, and it will ask us to confirm that we want to install a certificate into our Trusted Certification Authorities. Hit yes, and we can see there the import was successful. So that now means that we can navigate to our web apps in the browser without having any SSL connection issues. So you'll notice that alongside those certificate files, I also have this Docker Compose file that I have already created. It's simply just a bare bones Docker Compose file. You can see here at the top we're using version 3.9, which is the latest version at the time of recording. you can see that we have a services block, and within that services block we define a database service. This database service has an environment variable Postgres_password, and that equals password. The image for this container will be Postgres version 14. Again, that's the latest at the time of recording. The ports, we're exposing port 5432 from the container to our local machine. That will allow us to connect from our local dev environment into the database container using database administrative tools. And then you can see we have a volume mount there at the bottom, which is a named volume called DB, and that volume will map into the container at /var/lib/PostgreSQL/data. Now what that volume allows us to do is it will allow us to persist data in the database between sessions. So by default, without that volume in place, when we do a Docker compose down, it will delete the container, and in doing so it will also delete all of the database's data that was part of that container. So when we next run Docker compose up in that scenario, it means the database would be completely blank every time. However, with that volume mount like so, it means that data will be persisted across container sessions. So when we run Docker compose down, it will save the data that was in the database to that volume, so that when we next run Docker compose up, it will restore all of the databases and indeed all of the data that we had in those databases into the container. So that is our database container in our Docker compose file, and what I am going to do is simply click on these two arrows here and run Docker compose up. So what this will do is it will take a few moments to build that database image. The first time you run it, it will take a few extra seconds to pull down the Postgres image. However, once it's pulled it down for the first time, it will be cached, and so subsequent runs will be a lot quicker. If we expand these services, you'll notice that I now have a database container running over here on the left-hand side. And so what I'm going to do within a Rider is use the Database Explorer over here on the right, and I'm going to add a PostgreSQL data source. Now feel free to use other tools such as pgadmin, and indeed feel free to use any other database. I'll be using Postgres for this demonstration, for this sample, but feel free to use SQL Server, MariaDB, or any other database of choice. I'll highlight throughout the sample bits and pieces that you'll need to replace and modify if you're using a different database to store data. So you can see here the host is localhost, port 5432. The authentication, the user is going to be Postgres, like so, and the password is simply password. Again, this matches the environment variable that we set up in our Docker compose file. So if you chose a different password in that environment variable, make sure you set the appropriate password here when you're connecting to the database. I'll also get rid of the default database, and if I now hit test connection, give it a few seconds, and you can see that we have successfully connected to our PostgreSQL server. What I'll do is just come over here to schemas, select all databases, and then apply, and OK. And you can see over here on the right hand side, I now have a connection into the Postgres database that's running in our Docker container. It goes without saying, of course, you don't have to use a database inside a container. You could, for example, use a database as a service, such as Azure SQL Server, if you wish. However, for the purposes of this sample and to get up and running nice and quickly, it's very simple and straightforward to just spin up a database in a container when we're developing locally. So, what we can now do is to start adding some projects to our solution. So I'll collapse that database panel down on the right. I will close our Docker compose file. And what I'm going to do is right-click the solution node, add new project, and we are going to create an IdentityServer application. So this will be an ASP.NET Core web application. The type is going to be web app. Sorry, the type's going to be empty, not web app. and the name is going to be IdentityServer, like so. The language C#, framework .NET 6, and Docker support will be set to Linux, so we will enable Linux Docker support. If we then click on create, give it a few seconds to create that project, and then we will start work on the IdentityServer project. So now that we have our IdentityServer project, the first thing that we are going to want to do is to install some NuGet packages. So the first package that we are going to want is our Duend IdentityServer packages. So what we are going to want to do is install the Duend IdentityServer package. Install that one like so. We're also going to add integration with ASP.NET Core Identity. So we're going to want the ASP.NET Identity package. And we're also going to be using Entity Framework to store our Identity Server data. So we're going to want the Entity Framework integration package. Next up, we are going to be using ASP.NET Core Identity to store user data. And so we want to install the ASP.NET Core Identity Entity Framework Core integration package, which will allow us to store that user data in an Entity Framework backed database. So we'll install that package into the project like so. And then last but not least, we will install the Entity Framework Core packages. So for that, we are going to want the PostgreSQL Entity Framework Core provider. So we'll install that package like so. And we're also going to want the Entity Framework design tools. So for that, we'll come down to here, Entity Framework Core.design, and this will install the design time components to allow us to use the Entity Framework CLI, amongst other things. We'll install that package like so. And with all of those packages in place, you should therefore have the three Identity Server packages, ASP.NET Core Identities Entity Framework Core package, the Entity Framework Core Design package, and our Entity Framework Core PostgreSQL Database provider. So now what we're going to do is to set up ASP.NET Core Identity in the project. So what we're going to want to do first of all is to create a user model. So to do that, I'm going to add a new directory called models. And inside this folder, I'm going to add a new class called application user, like so. And this application user is going to extend our identity user from ASP.NET Core Identity, and I'm going to add a couple of additional properties over and above those provided by the base identity user class. So the identity user class comes with properties for a username, email address, phone number, amongst others, but I'm going to create a couple of properties in here, the first of which is going to be a user's given name or their first name, and also another property for their family name or last name. Feel free to create any other properties that you like in here, for example things like date of birth, etc. You can create those properties in here in this application user class. For the purposes of this demonstration though, I'm just going to go with given name and family name. So now that we have our application user class, we are going to want to create a database context class. So I'm going to create a data folder, and inside the data folder I'm going to create a new class called application DB context, like so. And this application DB context is going to extend from the identity DB context. And then what I'm going to want to do is insert a constructor like so, and this is going to take in our DB context options. Now it's important to note here, commonly if you have a single database context, then this is a perfectly satisfactory setup. However, because we will have multiple database contexts from both ASP.NET Core Identity and IdentityServer, we need to specify the type for this DB context options. Otherwise, dependency injection won't know which database context options to use for this database context, because there's more than one database context. So what we'll simply do is specify the type in there, application DB context. And that means that dependency injection will automatically pick up the correct DB context options for this class. So now that we have our database context, the last thing that we're going to want to do, you'll notice we have our custom user class. So where we have our identity DB context, we can specify type application user. And that will tell ASP.NET Core Identity that we want to use our custom user class, which extends the built-in identity user class. Now, last but not least, we are going to want to add a claims principal factory. Now, you're probably wondering what a claims principal factory is. Now, before I go into what the factory is, a brief overview of what a claims principal is. So when you sign into an ASP.NET Core web application, it will generate a claims principal. Now, that claims principal essentially stores claims about the currently signed in user. And claims are essentially properties or assertions about the current user. So claims could be things like username, email address, family name, given name, etc. And essentially a claims principal is a wrapper around all of those claims for the currently signed in user. Now, by default, ASP.NET Core Identity will generate a claims principal using the properties that are defined in the identity user class. However, you'll recall we created our custom application user class with given name and family name properties. Now, by default, because these are in our custom class, they won't be included as claims in the claims principal. So what we will need to do is create a custom claims principal factory that adds those additional claims for given name and family name. So when the user is authenticated, we will add those claims into the claims principal. So what we will do is create a new directory in here, and we will call this factories, like so. And then if I right click, add a new class, and this is going to be an application user claims principal factory, like so. I'm going to create that class, and this is going to extend from the user claims principal factory provided by ASP.NET Core Identity, and the type of our user is application user. You'll notice we have some missing members to implement, which is just the constructor calling the base class's constructor with a user manager and an options accessor. Now, if we take a look in the user claims principal factory, take a look at the code inside this factory, you'll notice we have this generate claims async method. And this is what will generate a claims principal, claims identity for the currently authenticated user. You can see here it adds claims for user ID and username, also a claim here for email, amongst others. So what we need to do is overwrite this method to also add claims for given name and family name. So what we can do just beneath our constructor is we can override the generate claims async method, and we can say var claims identity equals await base generate claims async. That means that it will use the logic from the base class to generate those base claims into the claims identity. And what we're then going to want to do is say if user dot given name is not equal to null, then we're going to say claims identity dot add claim, and then we'll say new claim JWT claim types dot given name, and the value will be user dot given name. And then, as you can probably guess, we will do the exact same thing again for family name. If the family name is not null, then add a claim to the claims identity for the family name. JWT claim types dot family name with a value of user dot family name, like so. And then we can return that claimed identity with our couple of extra claims for given name and family name. Again, if you added additional properties into the application user class, things like date of birth or whatever took your fancy at the time, then feel free to adjust this generate claims async override as appropriate to add those properties as claims for the currently signed in user's claims principal. Again, you may not want those claims to be added to the claims principal, and in which case you don't need to add this claims principal factory. You can simply use the one provided out of the box by ASP.NET Core Identity. But because we want to add given name and family name to the claims principal, we need to add our overriding application user claims principal factory. So now that we have our application user model, our application DB context, and our application user claims principal factory, we can now look to add identity to our startup. So if we come into the program like so, you'll notice fairly bare bones at the moment, but what we can do is we can add our database context. So that's builder.services add DB context, our application DB context, and then inside here we have an action with service provider and DB context options builder. What I'll do is I will just rename these to make it clear exactly what they are. And what we're going to want to do is say DB context options builder dot use npg SQL, which will set up this DB context to be backed by our PostgreSQL database. And I'm going to say service provider get required service iConfiguration dot get connection string, and I'm going to store the connection string with a name of just identity. Again, feel free to use any particular name you like in there, and I'll show you where you need to adjust that accordingly if you do choose to use a different name. And then what we're going to want to do is update the options for the database to add our migrations assembly. I'll just rename that options builder to make it clear. And then what we're going to do is say npg SQL db context options builder dot migrations assembly, and this is going to essentially be the assembly that the migrations are stored in. The assembly being essentially the project that contains those database migration classes. I'm going to say type of program because I'm going to store the migrations in this project, and then I'm going to say get type info, and then dot assembly dot get name dot name, like so. And that will essentially set up the entity framework provider to use this project, this assembly, to look for migrations and indeed store migrations. So what we can now do is add identity itself. So just under our DB context, we can say builder.services.add identity. We're going to use our custom application user type. However, we will just use the built-in identity role type. Again, if you wanted to add custom properties to that role class, then much like we've done for the application user, you could add an application role class, and you can add any additional custom properties into the role model. But the built-in identity role model provides everything that we need for this particular sample. What we'll then do is add our claims principal factory. That's our application user claims principal factory, like so. We can then add the default token providers, and finally we can add entity framework integration using our application DB context. So that essentially is identity set up and configured in our startup logic. You can see down here we've got this app map get, this boilerplate. We can get rid of that like so. And what we're going to want to do now is generate a database migration for our identity database. Now what I'm going to do is come into the app settings.development.json, and I'm going to add a connection strings block. Now you'll recall I named the connection string identity. If you named it something different, then make sure that key matches whatever you named the connection string. And the connection string is going to be server equals a local host like so. The port is going to be 5432. Database is going to be just called identity. Again, feel free to call the database anything that you like. The user ID is going to equal Postgres. And finally, the password is going to equal password, like so. That is the password that we defined in the environment variable in the Docker Compose file. So once again, if you chose a different password in that environment variable, make sure you set the password here appropriately so that it matches the Postgres password environment variable value. Now that we have our identity connection string, we can come down to the terminal. We can cd into that identity server project, and we are then going to want to add our database migration. Now to do that, you're going to want to make sure that you have the Entity Framework tools CLI installed locally. You can install those with .NET Tools install .NET EF. Make sure you install those globally. And then once you've got those tools installed, you can run this command here to add our identity application DB migration, pointing to the application DB context and outputting that migration file to data, migrations, identity, and then application DB. So if we run that command, it will build our identity server project, and it will then create a migration for our identity database context. So as you can see there, if we now come up to our data folder, we have this migrations folder, identity, application DB. And you can see within here, we have all of our ASP.NET identity tables. And if we take a look at our ASP.NET users table, you can see we have the custom properties for given name and family name. If you chose extra or alternative custom properties, then you should see them here in this ASP.NET users table. So now that we have those that migration created, we can now look to create the identity server on top of our ASP.NET Core identity. So if we collapse those folders down, and if we come back into our program file, we are going to now add identity server. So what we're going to do is say builder.services.add identity server, like so. And we're going to add ASP.NET Identity integration. And this is going to use our custom application user class. Then we are going to add the configuration store and also the operational store. The configuration store essentially stores configuration data for Identity Server, that being things like API resources, API scopes, and clients, amongst others. And the operational store stores, as the name suggests, the operational data. So that's things like signing keys, tokens, and the data that's needed for the day-to-day operation of the identity server. So what we are going to want to do inside these configuration store and operational store is use these option actions to customize the configuration options. So first of all, the configuration store options, we are going to say resolve DB context options, and that will give us a callback with service provider and DB context options builder, like so. Much like I've done above, I'll rename these to make them verbose and clear as to exactly what they are. And then in here we're going to say DB context options builder, use npg-SQL. Again, these will be in a PostgreSQL database. However, what I'm going to do is use a different connection string to the one above. So I'm going to say get requires service, iConfiguration, and then get connection string, and I'm going to call this connection string identity server, like so. Now, I am going to store the user data in an identity database, and then I'm going to store the identity server data in an identity server database. And that gives us quite a nice separation of concerns, where user data is in its own separate isolated database. And that means that we can add, appropriate sort of toughened security to that user database because of course that's going to store sensitive data such as email addresses and other personally identifiable information. So having them in separate databases gives you a nice separation of concerns and makes it nice and clear having the user data in an isolated separate database by itself. What I'm then going to do, much like we did above, is use the PostgreSQL options builder to update the migrations assembly. So in much the same way as we've got above, I can say PostgreSQL DB context options builder dot migrations assembly. This is going to be type of program dot get type info dot assembly dot get name and then name, like so. Now you may have noticed that these two actions are identical. So what we can do is we can come up to this top one here and we can refactor this to a local function, PostgreSQL options action, like so. And what I'm going to do is then move this to the bottom of the file, and I can then refer to that exact same function from within this configuration store options. PostgreSQL options action, like so. Now we're going to want to do the exact same thing again for the operational store options. I'll just rename that to make it clear this is the operational store and not the configuration store. And then much like we did above, we can say operational store options dot resolve DB context, and I'm going to store the operational data in the same database as the configuration data. So we'll have a single IdentityServer database with all of our IdentityServer data contained within it. So what I'm going to do is I'm going to refactor this to a local function, much like we did below. And then I'm going to come down here, move that down to the bottom, and then I can simply say equals resolve DB context options. And essentially that will now set up our configuration store and our operational store to use our Postgres database. And with that in place, we are now going to add migrations for the configuration DB context and the persisted grant DB context. So if we come back into our app settings.development, we're going to add another connection string for our IdentityServer database. Again, if you chose a different connection string name, then make sure you enter the appropriate key for this connection string in the app settings. So much like above, this is going to be almost the exact same, with one difference being the database name. Our identity data will live in an identity database, and the IdentityServer data will live in an IdentityServer database, like so. What we can now do is come back to our terminal, and we can cd once again down into the IdentityServer project, and we can now add our database migrations. So the first database migration is going to be for the configuration DB context, and we're going to output this into an IdentityServer folder within our migrations folder. So if we run this command, give it a few seconds to build the project, and then this will generate a migration for the configuration DB context. And then we're going to want to do the same thing again for the persisted grant DB context. So for that, we will use the context persisted grant DB context, and we will output this into a persisted grant DB folder within our migrations folder. Give it a few moments once again, and you can see we now have those two migrations created. So if we look in our data migrations folder, we have identity and IdentityServer. With an IdentityServer, we have persisted grant DB and configuration DB. As I mentioned earlier, the configuration DB context will store the configuration data, things like API resources and clients, etc. And the persisted grant DB will store the operational data, things like signing keys, tokens, etc. So now that that is done, we can add some logic into the startup to seed the database. So just down here between our app equals builder.build and app.run, we're going to want to add some logic to create some data in our database if the data doesn't exist. So what we're going to want to do first of all is say if app.environment.isDevelopment. We're only going to run this seed logic in our development environment. And then we can say using var scope equals app.services.createScope. And then we can say await scope.serviceProvider.getRequiredService application db context.database.migrate async. And that will migrate the database for our application db context. And as you might have guessed, we're going to want to do the exact same thing for both of the IdentityServer db contexts. So that is configuration db context and the persisted grant db context. This will ensure that whenever our application is running in development, the database is always migrated and up to date with the most recent migrations for those database contexts. Next up, we can say var user manager equals scope.serviceProvider get required service, and we can say user manager with our application user type. And this user manager will allow us to essentially interact with the user store for ASP.NET Core Identity. So what we're going to do is say if await user manager dot find by name async, and I'm going to create a user with a username thomas.clark. Feel free to choose any username that you like, perhaps your name. And we're going to say if that equals null, then we're going to add a user into the database. So we'll say await user manager dot create async. This will be a new application user, and the username is going to be thomas.clark. We're going to give the user an email address of thomas.clark@example.com, and the given name is going to be Thomas, and the family name is going to be Clark, like so. And then I'm going to give the user a password of capital P A55W0RD exclamation mark. Again, feel free to use an alternative password as long as it meets the default requirements within ASP.NET Core Identity. So, what this block of code is essentially doing is going to the database and attempting to find a user matching the username thomas.clark. If there is not a user with that username, then it will come into this block here and it will create that user in the database with a password of PA55W0RD exclamation mark. So that is our user being seeded into the database if it doesn't exist. And we're now going to add the configuration data for IdentityServer. So what we're going to do is say var configuration db context equals scope.serviceProvider get required service. This is going to be our configuration db context, like so. And we are then going to say if await configuration db context dot API resources dot any async. This basically is going to check to see if there are not any API resources, and if there aren't any, then we're going to add an API resource into the database. So we can say await configuration db context dot API resources dot add async. This is going to be a new API resource, importing the API resource model and not the API resource entity. And we're then going to use toEntity to map that model to a database entity class using the entity framework mappers provided by IdentityServer. So we can do that like so. And then we are going to add some properties for our API resource. The first one we're going to add is the name. Now I'm going to use GUIDs for the names and identifiers Feel free to use any unique string you like. It doesn't have to be GUIDs. As long as it's a unique string for the name of the resource, then you can use any string you like for this value. So the name is going to be a new GUID. The display name is going to be just API. And then we are going to assign it a scope. So this is going to be a list of strings. And the scope is going to be https www.example.com/API. The https www.example.com being essentially a namespace, if you like, and then the scope itself being API. Feel free, if you're working in a corporate environment, to use an appropriate URL as the namespace for the scope. So what we're then going to do is say await configuration db context dot save changes async, and that will add our API resource into the database. So next up, we are going to add that API scope. So we can say if not await configuration db context API scopes dot any async. If there aren't any API scopes, then we can say await configuration db context dot API scopes dot add async. This will be a new API scope with to entity on the end again. And this API scope is going to have a name of https www.example.com/API. It's important that the scope's name matches the scope that we defined above in the API resource. Both of those need to match up, otherwise you'll get issues when sending requests to that API. So make sure the scope name there matches the scope defined above in the API resource. And then finally, the display name, we will simply use a display name of API. And we can then say await configuration db context save changes async. And that is our API scope created. So now we have API resources, we have API scopes, and we're going to do the same thing now for clients. So we'll say if not await configuration db context clients any async. If there are no clients in the database, then await configuration db context dot clients. This time we're going to use add range async because we're going to be adding multiple clients. We can say new client dot to entity. And we are first and foremost going to create a client for a console application. This is going to use the client credentials grant type or client credentials flow. And so we're going to set it up with a client ID. Once again, I'm going to use GUIDs, but feel free to use any unique string, doesn't have to be GUIDs. We're going to define a client secret for our console application. So for this, we will say a new client secret with the value secret, and then we will hash that with SHA-512. Again, feel free to use any secret you like, and I'll point out later on when we get to it where you need to replace that value accordingly if you do use a different value for the secret. Next up, we will create the client name as just console application. Then we'll specify the allowed grant types, and this is going to be grant types dot client credentials. Our console application will be using the client credentials grant type to get access tokens. And then we'll specify allowed scopes, and the allowed scope that the console application will be able to use will be our https www.example.com/API. Again, that needs to match exactly the name of the API scope and indeed the scope that's assigned to the API resource. They should all match exactly for everything to work without issues. Now, what I'm going to do in our API project a little bit later on is set up Swagger UI. Now, a little bit of a side note, Swagger UI, of course, is running in the browser client side as a JavaScript, and so it needs to be set up in IdentityServer with CORS origin. Now, in order to test out the authentication in the Swagger UI, I'm going to use the client credentials for our console application, but that does mean that we need to add the Swagger UI as an allowed cause origin, because the Swagger UI will be making a cause request to IdentityServer to get an access token. So because we're using the Swagger UI, I'm going to add a new list here, and I'm going to add in here the HTTPS API and then port 7001, which will be the URL that our API will be running on when we get to that part a little bit later. If you're not interested in authenticating through the Swagger UI when you're browsing the API sort of documentation, then feel free to leave that allowed cause origins out. I'm simply adding it there for development purposes so that when we come to use the Swagger UI, we can authenticate via a cause request in the browser through the Swagger UI JavaScript client side. So that is our console application defined, and what I'm going to do now is create a new client for a web application. So this will once again be a new client, .to entity, and this is going to use the auth code flow with Pixie. So I'm going to define a client ID, which is going to be a new GUID once again. As I mentioned earlier, feel free to use any unique string to identify the clients. I'm going to set up this client with a secret. Much like we did above, I'm going to simply use a secret of secret and then hash it with SHA-512. Feel free to use any other value for the secret, and I'll let you know where you need to change it accordingly a little bit later on when we get to that part. I'm then going to create a client name of web application and the allowed grant types. The grant types is going to be the code flow. So we're going to say grant types dot code. And then we are going to add in the allowed scopes. Now, because this is an interactive client, it's not just going to have the API scope, it's also going to have the OpenID, profile and email scopes. The OpenID scope allows us to get the user's identifier. The profile scope allows us to get the user's profile information, such as first name, last name, username, etc. And then the email scope allows us to get the user's email address. And of course the API scope on the end will allow us to send requests to the API. So this will be a list of strings. And inside here we're going to have OpenID, we'll have profile, we'll have email, and we'll have https www.example.com/API. And those are our 4 scopes for our web application. Next up, we are going to want to define the redirect URI. The redirect URI is where IdentityServer will redirect back to after the user has authenticated. Essentially, the flow works by you opening the web application. You'll then, for example, hit a login button, and that will redirect you to IdentityServer, where you will log in. And then once you've logged in, IdentityServer will then redirect you back to the web application. And the redirect URI that you are directed back to in the web application needs to be registered here in IdentityServer so that it's able to validate and make sure that is a safe redirect URI to redirect back to after the user has signed in. If you don't add the redirect URI here into IdentityServer, then you will receive an error when redirecting back to the web application from IdentityServer. So the redirect URI, it's a list of strings, but we will just add one. And this will be https://web application running on port 7002. And this is going to be signin-OIDC, which is the standard OpenID Connect redirect URI in an ASP.NET Core web application. Last but not least, we have the post logout redirect URIs. And this is the exact same thing, but instead of after sign in, it's after sign out. So when the user signs out of IdentityServer, this is a list of redirect URIs that the user can be redirected back to after they've signed out from IdentityServer, going back to the web application. This is once again a list of strings, but we will just define the one redirect. And this is going to be https://web application port 7002. And this is going to be sign out, callback, OIDC, like so. Again, that's a standard sign out callback provided out of the box with OpenID Connect in an ASP.NET Core web application. Now, last but not least, we are going to define a client for a single page application. So we'll set up again a new client.toEntity, like so. Now, this client is going to be for a single page application, which means it's a public client or non-confidential client. All of the clients we've defined so far have been confidential clients. They're able to securely store a client secret because they are all running server-side in the backend. However, a single page application is inherently running client-side in the browser, which means that the JavaScript source code is completely viewable and browsable by the end user. That means that we cannot securely store a client secret in the single page application source code. Otherwise, the client secret would be viewable by anyone browsing the source code in their web browser. And that means that the client could then be compromised. So what we will do, much like we've done for the others, is use a new GUID for the client ID, like so. However, we will not use a client secret. And so what we can do is we can say require client secret equals false. And we will be using again the auth code with Pixie flow, which is the recommended flow at the time of recording for a single page application. Formerly, the recommended flow was the implicit flow. However, that has now been deprecated in favor of the auth code with Pixie flow. Again, that information is correct as of the time of recording. However, as with these things, they can be quite fast moving, so it's always worth doing a bit of research at this particular time to make sure that you're using the most appropriate and most secure flow or grant type for your application type. So we have the client ID, we set require client secret to false. I'm then going to create a client name of single page application, like so. And then as well as the client name, we're going to have the allowed grant types, which is going to be grant types.code. And then we're going to say the allowed scopes, and this is going to be the exact same as the allowed scopes for the web application. So I'll just copy those for ease. That's OpenID, profile, email, and our www.example.com/API. Next up, this is a JavaScript application running in the browser, which means that it will be making cross-origin requests in order to get an access token. So we need to specify the allowed cause origins for this application. This is a list of strings, but we will just add the one string, and it will be http://single page application running on port 7003. And this is our essentially the origin for the single page application. This means that it will be able to send a cross-origin request from the JavaScript single page application into the backend IdentityServer. And what we are then going to do is set up our redirect URIs. So the redirect URI is going to be http://single page application, again port 7003. This will be /authentication/login callback, like so. And then our post logout redirect URI. Again, it's a list of strings, but we will just have the one value. http://single page application port 7003, and this will be /authentication/logout callback, like so. And that is our post logout redirect URI for our single page application. And those essentially are our three clients: a console application, a web application, and a single page application. So what we can then do is say await configuration db context dot save changes async. Now finally, last but not least, we will need to add identity resources into the identity server. You'll notice we've set up the scopes for OpenID, profile and email, which means we will need to add those three identity resources into our identity server configuration. So much like we've done above, we can say if not await configuration db context dot identity resources any async. If there are not any identity resources, then we can say await configuration db context dot identity resources dot add range async. We're going to be adding the three identity resources: OpenID, profile and email. And we're going to say new identity resources dot OpenID dot to entity, and then we'll say new identity resources dot profile dot to entity, and then last but not least we will do the same thing again for the email identity resource dot to entity. Again, there are other additional identity resources such as phone, address and offline access. You may choose to add those in. For the purposes of this sample, we'll just stick with the three common ones: OpenID, profile and email. However, feel free to add in the other identity resources for address, phone number, offline access, etc. And you can also add in custom identity resources if you have particular requirements for your application. What we can then do is say await configuration db context dot save changes async, and that will add in our three identity resources. So now that our logic is in place to seed the database, as you can see at the top, just to recap, it will migrate those three database contexts. It will then create a user if one doesn't exist, and it will then add an API resource, an API scope, three clients and three identity resources. So what we are now going to do is we are going to add the identity server user interface. Now for that we can use the identity server quick start UI that is provided in the Duend identity server repositories. So if I come into the terminal, cd into the identity server project, and we can run this PowerShell command here to essentially pull down the identity server ASP.NET Identity UI from the identity server repository and add the user interface into our project. So what I'm going to do is run that command. It takes a few seconds to pull down that archive and then add it to the project, and that will then give us the identity server UI. So as you can see there, it's just pulling down the user interface from the identity server repository. It's quite a sizable archive, so it may take a little while to do that on your machine. And you can see there it's expanding the archive, and we now have a pages folder and a www root folder. So if we pop back up here, you can see there www root and pages. And that is now the identity server UI code added to our project. Now you will notice when you pull it down for the first time, there are likely going to be a few errors. So if we come into pages, into account, login, and come into the code behind, you'll notice that it needs a using statement for the application user class. So what I will do is I'm going to import missing references in file, and I'll do that for the entire project. And this will go through scanning the entire project for any using statements that it needs to add. It'll take a few seconds, and you can see there it's now added the appropriate using statements. And what I'll do is also get rid of any redundant using statements to tidy up any errors that have been left behind by those incorrect using statements. So remove unused directives in project. That will go through and scan for any unused using statements. And you can see there that's now gotten rid of all of the errors in the pages directory. It's purely because the namespace is different to that of the IdentityServer sample UI. So you'll probably find that in your project, depending on what you call the IdentityServer project, you may well find a few namespace issues, and you might just need to go through and fix up those using statements. But that's super quick and easy to do, just using the IntelliSense provided by Rider. Now if we come back into our startup, there's a little bit of logic that we need to do to actually make the application use that user interface. So underneath our add identity server, we're going to say builder.services.add Razor Pages. That will add Razor Pages support and the appropriate services into our application. The Identity Server UI is at the time of recording built using Razor Pages. And then if we come down to our middleware, we're going to want to set up some middleware for our application. So we can say app.use HTTPS redirection. We can say app.use static files. Static files means that it will pick up the static files in the www root folder. We can then say app.use routing to ensure that routing is configured appropriately so we can navigate around the different pages in the browser. We can then say app.use identity server, and that will add in the identity server middleware into our application. We can then say app.use authorization, which will allow us to use the authorize attribute in our Razor page code behind files. And then last but not least, we can say app.map Razor Pages, and that will then map the Razor page setup the appropriate ASP.NET Core middleware for Razor Pages. So that is our program file modified and ready to go. And last but not least, we can show all files, come down to our Docker Compose file, and we are going to add a service for our identity server. So this service is simply going to be called Identity Server, like so. And this is going to build, and the context is going to be the root directory of the solution. And the Docker file is located in IdentityServer/Dockerfile. Now the reason I've got the context and Dockerfile split there in two separate lines, because the context I want to be the root of the solution, and the Docker file itself is nested inside the Identity Server project, as you can see just here. And that's required because out of the box, the default Docker file, as you can see here, relies on the Docker context being in the root of the solution. You can see the file path here, identity server / the CS_proj file. That means it will need to be executing that copy command from the root of the repository. So that's why we specify the context to be at the root of the solution, and the Docker file then to be nested one level down within the Identity Server project. So that is the build configured there. We're going to specify that this depends on the database. We require the database to be running before starting the Identity Server. And then what we can do is specify a custom entry point. So this is going to be a shell script, which is going to run the command update CA certificates, and then run .NET IdentityServer.dll. And essentially that update CA certificates is going to allow the container to trust our self-signed certificate before it then spins up the Identity Server application. Now that's required because we're using a self-signed certificate. By default, the Linux container doesn't trust that self-signed certificate, and that means that SSL HTTPS connections between the containers will fail because the container won't be able to validate and verify the genuineness of the self-signed certificate. So running that update CA certificates will make sure that the container trusts our self-signed certificate, and then it will spin up the identity server application via .NET. Now you could of course add the certificate into the Docker image itself, but that's generally not recommended because that means that the Docker image then contains our self-signed certificate across all environments. It's best practice to keep that Docker file as clean as possible, and that means that you can then use the same image both locally during development and indeed in production. And you can simply mount certificate files into the container locally. You can specify the environment through things like environment variables, and that means you then have a good level of satisfaction knowing that if the image is running locally, then chances are it will be running fine in production because it will be the exact same Docker image. Saves having to build multiple images differently for running locally, running on staging, integration, and running in live in production. So what we will then do is define a few environment variables. The first one is going to be ASP.NET Core _environment, and we're running this locally as development, so we will specify the environment to be development. We'll then specify ASP.NET Core _URLs. This is going to be running on HTTPS, and we're going to run it on port 7000. Next up, we're going to specify ASP.NET Core, and then Kestrel, and then 2 underscores, certificates, 2 underscores again, default, 2 underscores again, and then password. And this is the password that we used when we exported the PFX file back at the beginning of this video. If you used a different password for the PFX file, then make sure you update this environment variable appropriately so that it matches the password you used when you exported the PFX file. Next up, we're going to have another Kestrel environment variable. This time it's going to be Kestrel certificates defaults and then path. This is going to be the path in the container to that localhost.pfx file. That's going to be https localhost.pfx. And then what we're going to want to do is add our connection strings. So we're going to add a connection string for identity. This is going to be server equals a DB, port equals 5432. The database is going to equal identity. The user ID is going to equal Postgres. And then the password is going to be password. Again, the password for the database there should match the Postgres password environment variable that we defined for the database container. So make sure that matches the database password for your Postgres server. And indeed, if you're using an alternative database such as SQL Server or MariaDB, then make sure you update the connection string appropriately for your database of choice. You'll notice that when we defined the connection string in our app settings, we used a server of localhost. That's because when we were running those entity framework commands locally on our local machine, the database was available via localhost port 5432. That's because we exposed the port 5432 from the Docker database container to our local machine. However, if we were to specify server localhost for this identity server connection string, that would then look in the localhost of the identity server container. And the localhost of the identity server container doesn't have our database in it. And so that server equals DB essentially tells Docker Compose when it finds that sort of magic DB string, it will automatically substitute that with the server address for the database container, which means that the identity server container is then able to talk to the database container using that DB magic string. So what we're going to do is copy that connection string and we are going to do the same thing for IdentityServer. This is going to be in a separate database called IdentityServer, so we just change the database from identity to IdentityServer. Again, the rest of the connection string can remain the same server, same port, same user ID, and same password. Next up, what we're going to do is to specify the ports, and you'll notice the ASP.NET Core URLs are set to run on port 7000. So we will open port 7000 from the container to our local machine, and that will allow us to go to the web browser, port 7000 on our local environment, and that will then route down through into port 7000 in the IdentityServer container. Next up, last but not least, we are going to specify a couple of volume mounts. So this is where we're going to mount our localhost certificates from our local file system into the containers file system. So first of all, we're going to specify localhost.pfx. That is our pfx file that we generated back at the beginning of this video. You can see it starts off there with the path in our local file system. And then the second part of the volume mount is going to be the file location within the container. And this is going to be /https:/localhost.pfx. You'll notice that matches the Kestrel certificate default path environment variable. It's important that those both match so that Kestrel is able to find that certificate to enable HTTPS connections using SSL. And last but not least, we will set that volume up as a read-only mount because we don't need the container to modify that file. It can simply be mounted as read-only for enhanced security. Next up, we're going to want to mount the localhost.crt file. And this is going to be mounted into user local share ca-certificates and then /localhost.crt. Again, this is going to be a read-only volume mount. And what that's going to do is it's going to mount the localhost public certificate into the CA certificates folder, which means that it will then be picked up when we run the command update CA certificates. That means that the certificate will then be trusted, and so SSL HTTPS connections will then work between containers because the certificate will be a trusted, valid certificate in the container. So that is our identity server configured in our Docker Compose file. And what I'm going to do briefly, in our Docker Compose deployment, I'm going to edit that configuration. And what I'm going to do under the modify options, I'm going to come down to build, and I'm going to specify that I want it to always build the images before starting the containers. This is useful when you're running locally because otherwise, if it's already built the image once, it will simply use the image that it's already built and got cached, which means that our local changes won't then be picked up when we rerun the Docker containers. So specifying the build option as always, which if you're running on the command line, equates to --build. That means that it will always build an image with the latest code changes in it. I'll hit apply and OK. And then what we can now do is, again, click on the run button just up here, and this will now build our identity server container. So this will take a few seconds the first time it runs. It will pull down the ASP.NET Core images for the first time. Once it's pulled those down once, so they will be cached, and so it will be a lot quicker on subsequent builds. And you can see there we have two containers now running. And if we expand our Docker Compose, we have our database container and we have our identity server container. So now what we can do, if we go into the web browser, we can go to https://identity server running on port 7000. Now this does rely on you having the appropriate host entries in your host file. So what you're going to want to do is make sure that you have an entry for identity server pointing to your local host in that host file. And that will mean that we can then go to IdentityServer, port 7000 in the browser, and we have our do-end IdentityServer running. If we click onto our discovery document, give it a few seconds to load for the first time, and we can then view all of our OpenID configuration for our IdentityServer. Essentially, the discovery document contains all of the configuration for OpenID Connect, which will allow OpenID Connect based client applications to get the appropriate configuration to get an access token, etc. So that is our IdentityServer up and running. So now what we can do is we can create an API project. So I'll close our Docker Compose for now. And if I come back to the solution node up here, I'm going to add a new project. And instead of type empty, I'm going to select type web API. And this is going to be named as just API. Again, feel free to name it whatever you like. The type web API, language C#, no authentication because we will add that manually ourselves, and we'll enable Linux Docker support. So if I give it a moment to create this project, you can see here we now have our API project in the solution. Now what I'm going to do is right click, manage NuGet packages, and we are going to want to add the JWT bearer authentication package. So we'll add this package here into that project, like so. And while we're here, we'll also update the Swashbuckle ASP.NET Core package to its latest version. So there we have our two packages for our API. We have Swashbuckle ASP.NET Core, which will allow us to use Swagger. And then we have our ASP.NET Core JWT Bearer Authentication package. So what we'll do, if we come into the program file here, we will set up authentication and authorization in our API. So what we're going to do is say builder.services, add authentication. This will be JWT Bearer defaults authentication scheme. And then we'll say add JWT Bearer, like so. This will give us an options action. And I'll just rename those options to make it clear those are our JWT Bearer options. And in here we can specify the authority for access tokens. And that's going to be builder configuration. And I'm going to store that under a key of authentication and a key of authority, like so. I'm also going to set up the audience, so builder.configuration, and that will be authentication : audience, like so. And then I'm going to set up the token validation parameters. So that's JWT Bearer options.token validation parameters. And I'm going to set validate audience to be true. I'm then going to do the same thing again for validate issuer. And I'm going to set that to true. And I'm also going to do the same thing again for validate issuer signing key. That means that the API will validate the signing key that was used to sign the JSON Web Token. That will basically ensure that a fraudulent third party can't create a JSON Web Token with the authority and audience and pass it to our API, because it will require the token to be signed by our IdentityServer, which adds that extra layer of protection to ensure that only tokens signed by our IdentityServer are going to be accepted by the API. And then next up at the bottom here, we can simply say app.use authentication. So that is authentication configured in the API, and what we can now do is configure the authorization. So what I'm going to do here is say builder.services.add authorization, and this will give us an authorization options action. And again, I'll just rename that to make it clear. This is the authorization options. And in here, we can say add policy. Now I'm going to call this policy API scope, but feel free to call the policy anything you like, anything that you deem appropriate. I'll then use this policy builder, and again I'll just rename that to authorization policy builder so it's clear. And then we'll say authorization policy builder dot require authenticated user, and then require claim. Now this claim will be of type scope, and the scope is going to be our API scope. That's www.example.com/API. And that will basically mean that any controllers or indeed endpoints set up with this API scope authorization policy will require a scope in the JSON Web Token of https www.example.com/API. And you can see here down at the bottom we have then app.use authorization already in place, ready to go. So now what we're going to do is configure that authorization and authentication in Swagger. So what I'm going to do here, you can see we have add Swagger Gen, and this will give us an options action like so. Much like I've done above, I'll just rename that to make it clear. And then we're going to want to say Swagger Gen options, and we're first of all going to start with the Swagger doc. So this is going to be v1 of the API, and then we will set up some OpenAPI info. The title of the API, I'm just going to call it API. Feel free to call it anything you like. And the version I'm going to set as just v1. And that's the OpenAPI docs for the API created. And now we're going to look at creating a security definition. So we can say Swagger Gen options dot add security definition. And this is going to be named OAuth2. Again, feel free to name it something different if you like, and I will let you know where you need to update that if you do name it something different. Then we can say new OpenAPI security scheme. This is going to be an OAuth2 security scheme, and the flows are going to be new OpenAPI OAuth flows, and we are going to set up the client credentials flow. So this is going to be a new OpenAPI OAuth flow, and this is going to want the token URL, and for that we can say builder.configuration authentication:authority, and then we can say /connect/token, like so. And then we can wrap that in a new URI. And then we are going to want to define these scopes, and that's going to be a dictionary with the key being the scope, so https://www.example.com/API, and the value is going to be the display name, which in our case will just be API. And that is our security definition created now for the Swagger UI. And so what we are going to do now is add the security requirement. By default, that security definition won't actually make any changes to the UI. The security requirement is what will add the little padlock icon onto the endpoints to prompt people to authenticate before sending a request using the Swagger UI. So we can say Swagger Gen options, add security requirement. This will be a new OpenAPI security requirement, and the key is going to be an OpenAPI security scheme, and this is going to be a reference to the security scheme that we created previously. So the type, the reference, is a new OpenAPI reference. The type of that reference is going to be a type security scheme, and you'll notice it also takes in an ID, and this ID should match the name of the security definition that we created just above with our OpenAPI security scheme. So the ID here and the name up here should both match in order for the reference to pick up the correct security scheme. And the value for this is going to be a list of scopes that apply to that security requirement. So we're going to use the scope www.example.com/API, basically meaning that in order to send requests to the endpoints, you are going to be required to have the API scope as part of that security requirement. And then if we come down to the bottom, you'll notice if we're running in development, we already have use Swagger and use Swagger UI set up. If you want to enable Swagger in production, simply get rid of this if statement and then just keep use Swagger and use Swagger UI, and those will then run across all environments. But by default out of the box, it will just be running during development. So next up, last but not least, because we're going to be calling this API from a single page application a little bit later on, we are going to need to set up cores to enable cross-origin requests. So what I'm going to do is come down to here and say builder.services.add cores. Inside here you'll notice that we have some cores options. Again, I'll just rename that to make it clear. And inside this cores options we can say add a default policy. This will give us a cores policy builder. Again, I'll just rename that as cores policy builder. And then we can say cores policy builder dot allow any origin, allow any method, and then allow any header. And that will set up cores to allow any origin with any method with any header. Again, your use case, you may wish to limit the origins that are allowed to call the API to a specific subset of origins, but for the purposes of this sample, we'll open up to any origin with any method and any header. And then last but not least, if we come down to our middleware, we can say app.useCores to add the cores middleware to the middleware pipeline. So that's our API now configured. And what we can do, if we come down to our Docker Compose file, we can now add a service for the API. For ease, I'm going to make a copy of the IdentityServer service, paste it up here at the top, and I'm going to call it API. The build context is the same, the root of the solution, but it's going to instead be /API/Dockerfile. This is going to depend on just the identity server, sorry. So this will require the identity server to be running before running the API. Our entry point is going to be mostly the same, except we'll replace identity server with API. Our environment variables, we can keep those mostly the same. However, the connection strings we can get rid of, and we can replace those with our authentication. You'll notice in the program file for the web API, we set our variables as authentication:authority. When you're writing those as environment variables, you replace the colon with 2 underscores. That is the convention in .NET. Instead of using a colon, you'll use 2 underscores in the environment variables. So we can say authentication:authority, and that will be https://identityserver running on port 7000, like so. And we then define another environment variable for the authentication audience. And this is going to be the name of the API resource in IdentityServer. Now you'll recall earlier on we used a new GUID. If you use a different string, then make sure that you set the audience here appropriately. What we're going to do is go into the database. We'll give that a refresh, and we will come down into the IdentityServer database, into the public schema, and give that a moment to refresh the schema. You can see here we have our 26 tables. And if we look in the API resources table, give that a moment to connect and process, you can see we have our GUID for our API resource. So I'm going to copy that, and I'm going to paste it here as the audience for the API. Again, if you used a different value, for example, a different type of unique string, then make sure you update the audience here appropriately so that it matches the name of the API resource in the IdentityServer database. What we can then do is update the ports 7000 is already in use for IdentityServer, so we will run the application on port 7001, also making sure we update the ASP.NET Core URLs environment variable appropriately. And we can then keep the localhost PFX and localhost CRT volume mounts so that the container is set up with our self-signed SSL certificate. So what we can now do is we can come up to the top right and run that Docker Compose file. That will now build both the IdentityServer and the API projects. It will build those images and run the images in containers alongside our database container. You can see there those three applications are up and running. And you can see we have our API, our DB, and our IdentityServer. You'll notice the one thing that we do need to loop back and do now, if we come to the weather forecast controller in the API, you'll notice that this is configured to allow anonymous unauthenticated requests. So what we will do underneath API controller is add the authorize attribute, and that will then essentially mean that this controller and all of the endpoints within require the user to be authorized in order to consume data from those endpoints. So what we'll do now, we've just made that quick patch there. We will rebuild those images and respin up those containers. Give it a few seconds, and then we will take a look at the Swagger UI in the browser, and we can test out our security scheme for the Swagger UI. Give those a few seconds to spin up those containers. There we go, 3 out of 3 are running. And if we expand that, we can see the API, database, and IdentityServer are all running. So if we come to the browser, and instead of IdentityServer, we're going to go to API, port 7001/Swagger. And you'll notice here we have our Swagger UI with our weather forecast endpoint. And you'll notice we have the padlock there from our security requirement. So what we do just to test it, if we come down to here, click on try it out, and if we execute this request, you can see we have a 401 with the www authenticate set to bearer. That response header basically means the bearer is either missing or invalid, the bearer being the access token essentially. So it's indicating to you there that you need to provide a bearer token or an access token in order to authenticate. So what we'll do is we'll click on this authorize button up here, and you can see it's configured with our OAuth2 client credentials flow. Now the client ID and client secret we can get from the database. So what I'm going to do is come into the database, come down to our clients, and you'll recall we set up the console application for with the cause origin to allow us to use these client credentials in the Swagger UI to test it. We can verify that by looking in the client cause origins table. You'll notice our console application client has an origin for the API, https://API port 7001. So what we'll do is we will copy that client ID into the Swagger UI, like so. You'll also recall that we set up the console application with a secret of just secret. Again, if you chose a different secret, then make sure you enter the appropriate secret for the console application client here in the Swagger UI authorized dialog. We're going to select the API scope, and then we will click on authorize. You can see here that we have successfully authorized using that ID and secret. We've gone off to the token endpoint and successfully got an access token. You'll notice the padlock is now lit, which means that with a bit of luck, if we hit execute, you can see that we now have a 200 with a response containing our weather forecast data. What I will do just for reference is I'm going to copy this access token, and I'm going to go to jwt.io. This is a useful website crafted by Auth0, and this essentially allows you to debug JSON web tokens. So what I'm going to do is paste our JSON web token into the box there on the left, and you can see on the right we have a bunch of properties. So first of all, we'll take a look at the header. We can see here the algorithm that was used to sign the token was RSA 256. The key ID is beginning in 872, ending in Delta 69. And we can see the type of the token is an access token in the format of a JSON web token. AT being access token, JWT being JSON web token. So we can verify this quite nicely by looking in the operational data for IdentityServer. So if we come down to our IdentityServer database, you'll notice that we have a keys table. If we open up this keys table, you can see we have an RSA 256 algorithm, and you can see here the ID of the signing key is 872, ending in Delta 69. That matches the key ID that we can see here for the JSON web token. This is extremely useful when you're debugging and perhaps you're trying to work out why the signing key, for example, isn't valid. It's very handy to be able to debug the JSON web token, view the key ID, and make sure that the key ID correlates with a row in the IdentityServer database. And you can then browse the properties of that signing key in the keys table. So that's the header of the JSON web token. That corresponds to this red block here on the left. And the main payload is this purple block on the left. And you can see here, this has an issuer. The issuer is essentially who created and signed the token. That being our identity server running on port 7000. That is the issuer of the token. We can see the NBF, that stands for not before, and we can see there the token is not to be used before 8:41 local time. We can also see the IAT, which is the issued at time, and we can see that's the exact same time as the not before time. Those commonly are both the same, means that the token cannot be used before that issued time, just in case of any discrepancies with system clocks. It just makes sure that, in case there's a clock that's maybe running a bit fast, make sure that the token can't be used before that specific time. We then have EXP, which is the expiration time, and that again is 0941 local time. By default, out of the box, clients in IdentityServer have 60-minute expiration for access tokens. So you'll notice it was issued at 8:41, which means that it expires at 9:41. When we were creating those clients in the seed script for the database, you can also customize the expiration time for access tokens as part of that client creation process. And you can also go back retrospectively in the database and modify that expiration time as you see fit for your different clients. We then have the audience, and the audience is essentially who the token is intended for. So the issuer is the application that issues the token, and the audience is the application that's intended to receive the token. In this case, the audience is our API. You'll recall that GUID is the GUID of the API resource for the API in the IdentityServer database. We've then also got the scope, www.example.com/API, that being our API scope, allowing the token to be used to send requests to the API. We've then got the client ID, and the client ID is essentially the client application that requested the token. So that is the GUID of our console application client. Essentially, you have the client ID, which requests the token, the issuer, IdentityServer, that issues the token, and then the audience is, in our case, the API that receives the token. So that's the flow essentially. The client requests the token and the audience receives the token. And it's worth pointing out, if you have more than one APIs, then that audience can sometimes be a list of audiences. In our case, though, we just have the one API, which is why we only have one audience. If the token had multiple different API scopes for different APIs, then the audiences would be a list of multiple audiences, because the token would be intended to be used by multiple audiences, multiple APIs. And then finally at the bottom here, the JTI is the JSON Web Token ID, which is the unique identifier for this particular JSON Web Token. As I say, jwt.io is a very useful site to be able to come into and be able to debug your JSON Web Tokens. It's especially useful if something is going wrong during that authentication and authorization process. So if we pop back to our API, as you can see there, we have our successful response, and that is our API now up and running. So what we are going to do now is create our first application. So that is going to be a console application. So what we're going to do is right-click the solution, add a new project, and we're going to select console application. I'm going to give it a name of console application, C#, .NET 6 with Linux Docker support. I will create that application like so. And as you can see here, we have our basic minimal C# 6 .NET 6 console application. What we're going to do is, first and foremost, we are going to install the identity model NuGet package, and that will allow us to easily acquire an access token and send authenticated requests to our API. So we'll install that identity model package into the console application like so. We can get rid of this boilerplate code, and what we are going to do first of all is create an HTTP client for IdentityServer. So we will say using var IdentityServer HTTP client equals new HTTP client, and we are going to set the base address to be a new URI, and we are going to say environment.getEnvironment variable, and this is going to be authentication, 2 underscores, and then authority. And we will add the exclamation mark at there to make sure that this environment variable is it does exist. If it doesn't exist, then by inserting that exclamation mark there, commonly known as the bang operator, it will mean that an exception will be thrown, and that's what's known as the bang operator, because it will cause the application to go bang. So what we can then do with that HTTP client is we can go off and get the discovery document. You'll recall I showed you that earlier on. The discovery document contained all of the OpenID Connect configuration details. So what we can do is we can say var discovery document response equals await IdentityServer HTTP client get discovery document async, and that will go off to the IdentityServer discovery document endpoint and pull back all of that OpenID configuration for us. What I'm going to do is say console.writeLine discovery document response dot token endpoint, and that will basically log out the token endpoint to the console so we can verify that the token endpoint is correct. What I will then do next is say var token response equals await IdentityServer HTTP client dot request client credentials token async, and this is going to take in a new client credentials token request. This is going to have an address, and the address will be the token endpoint. Token endpoint being the endpoint that you can go to get an access token. Next up, we will set the client ID, and again we will use environment variables for this. So we'll say environment, get environment variable, authentication underscore underscore client ID with the exclamation mark at the end to make sure it's not null. Then we will specify client secret equals environment, get environment variable. Same thing again, authentication, 2 underscores and then client secret, exclamation mark at the end. And then last but not least, we will specify the scope, and that will be https://www.example.com/API. And that will then be our token response, and that token response will contain our access token. So what we then do, just for diagnostics purposes, is we will write the access token out to the console. You can see there console.writeLine token response.access token, and that will write the access token out to the console. Now what we're going to do is we're going to new up a brand new HTTP client, and we're going to use this HTTP client to send an authenticated request to our API. So inside the new HTTP client, we're going to set up default request headers. We'll set up authorization, and this will be a new authentication header value. The scheme is going to be bearer, because this is a bearer token, access token. And what we can then say is token response dot access token. And that will essentially add the access token to the authorization header for all requests that are sent with this HTTP client. So what we can then do is we can then say console.writeLine await HTTP client get string async, and we can say https://API port 7001/weather forecast, like so. And that will essentially then write out the string response from that weather forecast endpoint. And that is our super simple bare bones console application up and running. Last thing we will do is add it into our Docker Compose file. So if we come down to our dockercompose.yaml, and what I am going to do is copy the API service just for ease, paste it down here, and I'm going to name it console application. The build context, again, is the root of the repository, but this time the Docker file is going to be console application. Inside the entry point, we can keep update CA certificates, but replace .NET API.dll with .NET console application.dll. Now, because this is a console application, we can get rid of all of the ASP.NET Core environment variables. Those are redundant because this is a .NET console application and not ASP.NET Core. However, what we are going to want to do is adjust the authentication environment variables. So what we will do is we will specify the authority as the identity server, keep that the same as what we had for the API. We will then create an environment variable for client ID, and we will create another environment variable for client secret. Now, if we come back into our IdentityServer database, if we take a look at the clients table, our console application client ID, we can copy that from the clients table and paste it into our client ID environment variable. And you'll recall that we set up the client secret for the console application to just be secret. Again, if you chose a different secret, then make sure you update the value of that environment variable appropriately. This is not a web application, so we can get rid of the ports. There are no ports to open because this is just a console application running inside the container. And in doing so, we can also get rid of the PFX file. This is not going to encrypt any SSL connections. We just need to keep the certificate there so it's able to send HTTP requests with SSL. It won't actually be encrypting requests responses. It will just be sending SSL requests to the API container. And in the depends on block, we already have IdentityServer there, but this also depends on the API because it's going to send a request to that API container. So that is our console application Docker file updated. And so what we can do now is come up to the top right and we can run that Docker Compose. That will build those containers for us, and all being well, it will run our console application. So you can see there, it's just creating those containers and running them. We can see 4 out of 4. And if we expand the services, you can see our console application container has stopped. Now if we click on it, and then over here on the right, very handy, you can show the logs for the container. So what I'm going to do over here, click on those three dots, click on show log, and we can see here the reason the container stopped is because it's just a console application. So it runs the program file, and then once the program file is finished, it stops the container. It's not like a web server that's continuously running in the background. Console application will start, run the program, and then exit, hence why our container has stopped. Now you can see there it's logged out the access token endpoint for the identity server. It's also logged out the access token that it acquired from that token endpoint. And we can see there it's also logged out the weather forecast data that we've got from our API. So that is our console application up and running, sending an authenticated request using an access token from IdentityServer, sending that authenticated request to our API. So what we're going to do now is we are going to create a web application. So what I'm going to do is right click on the solution, add a new project, and this is going to be a web application. Under type, I'm going to select web app. I'll leave the name as just web application. Type web app. Authentication is no authentication because we will set that up manually for this application. And we will enable Linux Docker support for this web app. If I create that project, give it a few moments to spin that up for us. And you can see here over on the left, we have our web application project. Now, much like we've done before, first things first, right click the project, manage NuGet packages, and we are going to want to install the OpenID Connect authentication package. So this is the Microsoft ASP.NET Core Authentication OpenID Connect. We'll install that package into our project, like so. And we can now make a start on adding authentication into our web application. So what we do inside the program, you'll notice that we have an error here, web application.create builder. That is because web application is the name of the project, and it's also the name of the class in the ASP.NET Core Builder. So we simply just need to expand and specify the namespace explicitly to get rid of that error, like so. If you've named your application something else other than web application, then you won't have this issue in the program file. So what we are going to do is, first of all, say builder.services add authentication. And this will give us an authentication options that we can use to configure authentication. So we'll say authentication options dot default scheme equals cookie authentication defaults authentication scheme. That means that by default, the application will use cookies to authenticate the user. However, when it comes to signing in the user, we want to sign them in using OpenID Connect. That's our identity server. And so what we can do is we can override that default scheme with the default challenge scheme. And for that, we want to specify OpenID Connect defaults dot authentication scheme. That means when it challenges the user for authorization, it will use OpenID Connect. However, for all other purposes, it will use cookies. So what we can then do is we can say add cookie and then add OpenID Connect, like so. OpenID Connect gives us an options action, and in here we will specify the configuration for our OpenID Connect. So we're going to say OpenID Connect options dot authority equals builder dot configuration, and this will be authentication colon authority, much the same as we've done for our other applications. We'll then say OpenID Connect options dot client ID builder dot configuration authentication colon client ID. We're also going to specify the client secret. Again, this is a server-side web application, which means that it's able to store the client secret securely. So that's why we are using a client secret for this web application. because it's all done on the server side and not client side. We're then going to specify get claims from user endpoint to be true. That means it will go to IdentityServer, it will sign in the user, it will come back with an access token, and it will then use that access token to send a request to the IdentityServer user info endpoint. That user info endpoint will then return a JSON payload with details about the user who was authenticated with that access token. Essentially, that means that access tokens are kept nice and small and succinct, and it means there's no leaking of personally identifiable information in the access token. You can, if you wish, add the user's claims into the access token, but that will increase the size of the access token, and it also means that you then have potentially personally identifiable information, such as the user's email address, in the access token that you're then using to send between your different applications, for example the API. Using the user info endpoint means we can have a nice small access token and then get the user info manually from the user info endpoint using that small and minimal access token. We can then say OpenID connect options dot response type, and this is going to be response type code because we're going to use the auth code with PixieFlow in order to get our access token. Next up, we are going to want to add the API scope. So we'll specify https www.example.com/API. That is the scope for our API because we're going to be using this access token to send an authenticated request to our API. And last but not least, we're going to specify OpenID connect options.saveTokens equals true. And that will essentially save the access token, amongst others, in the authentication cookie that ASP.NET Core will generate for us. If we choose not to save the tokens, then it will still go off and sign the user in as a normal, but when it comes back with the token, that token will not then be saved, and it means we won't be able to use that token at a later time to send an authenticated HTTP request. So by saving that token in the cookie, it means we can then pull out the access token at a later time and use that access token in our HTTP requests from the web application to the API. So that's why we have a save token set to true there. And just above a use authorization, we can then say use authentication to add the authentication middleware into the application. Next up, we're going to want to add authorization. So I'm simply going to do builder.services.add authorization. And you'll notice that we already have the authorization middleware set up as app.useAuthorizations towards the bottom. So what we're now going to do is we are going to finally add an HTTP client into our dependency injection by saying builder.services.add HTTP client, and this will enable us to use the HTTP client factory from within our Razor pages. What we're going to want to do is come into our pages, right click and add a new Razor page. I'm simply going to call this Razor page API. Feel free to call it whatever you like though. So what I am now going to do, come into here and just update the name to API model so that it matches the other pages, and the model will then be API model like so. And if I take a look at one of our other pages to see what view data we've got, you can see that we have the title here, and I'm going to update that view data title to equal API for our API page. And then what I'm going to do is get rid of the boilerplate HTML that it generates for me. I'm going to have a pre-tag, a code tag, and inside here I'm going to say model.data. Now this will give us an error for the moment because we haven't defined that property in our code behind. So what I'm going to do is I'm going to come into here and I'm going to say public string data and then get and set, and that will now get rid of the error in our API UI page. And inside the code behind, I am going to create a property for the HTTP client factory. So that will be private HTTP client factory with just a getter, and then I will generate a constructor for that HTTP client factory, like so. And then what I'm going to do in our onGet method, I'm going to make that asynchronous. So I'm going to change it to onGetAsync, and I'm going to make it return an async task, like so. And then what I am going to do inside here is say using var HTTP client equals HTTP client equals HTTP client factory dot create client, and that will create me a new HTTP client. And what I'm then going to do is say HTTP client default request headers dot authorization equals new authentication header value with a scheme of bearer, and the value is going to be await HTTP context dot get token async, and I'm going to want to get the access token, which is all lowercase access underscore token, and that will get the access token from that cookie. You'll remember we saved the access token into the authentication cookie. It will pull out the access token from that cookie and add it to the default request headers for this HTTP client. So then what I can say is data equals await HTTP client get string async, and then the URL to our API, which is https API port 7001 / weather forecast. And last but not least, I'm going to want to make sure the user has signed in before they access this page. So what I'm going to do is add the authorize attribute up to the top of this API model class, and that essentially means that the user will have to be authorized and signed in and have the appropriate permissions before this page is then rendered. That means that there will always be an access token saved in the cookie for us to be able to add to the authorization header before sending the request to the API. So that is the API page created in our web application. And what I'm going to do is in the shared folder, open up the layout, and I'm going to take this privacy link and I'm going to change that to be a link to our API page. So I'm simply going to change the ASP page from /privacy to /API and update the name from privacy to API. And that means that we can then easily navigate to the API page using the navigation bar at the top of the web application. So what we can now do is we can now add that web application into our Docker Compose file. So much like we've done before, come down to the Docker Compose file. I am once again going to copy the API like so, come down to the bottom and paste it in, and I'm going to name it web application. The build context is the same, however the Docker file will be web application, and the entry point will be update CA certificates and .NET web application.dll. And this is going to depend on both the API and the identity server, much like our console application did. With an update the ASP.NET Core URLs to port 7002, that's the next logically available port, and we'll also update the ports in the web application section of the Docker Compose to be port 7002 so that it matches the ASP.NET Core URLs environment variable. Now the authentication authority is going to remain the same, identity server port 7000. However, we can replace the audience with client ID and also add in an environment variable for the client secret. Now this is going to be the ID and secret for our web application. So if we pop back into our database, open up the clients table, and you can see here we have our web application client. I'm going to make a note of that client ID, paste it into the environment variables. Again, make sure that you use whichever client ID you've created for the web application. Doesn't need to be a GUID as long as it's unique. Copy that into the client ID, and you'll remember when we were seeding the database, we used a client secret of secret. If you used a different client secret, then make sure you set the secret appropriately here in the Docker Compose environment variable. So that is our web application added to the Docker Compose file. And now what I'm going to do is spin up all of the images, build all of the images and run the containers, and then take a look at that web application. So in the top right, if I hit run, I'll let it build all of those images and then spin up those containers, and then we'll open up the browser and navigate to the web application. As you can see there, it's running 5 out of 5 of the containers. If we expand all of those containers, we can see the API, the database, IdentityServer, and the web application. Console application, as I mentioned earlier, as run and exited, as we'd expect. And so now what we can do in the browser is we can go to HTTPS, web application, port 7002, and this now loads up our ASP.NET Core Razor Pages web application. So what we'll do is we will click on this API link, and you can see we have been redirected to IdentityServer. So I'm now going to sign in with the username that I created during the seeding of the database. I used a username of thomas.clark. If you chose a different username, then obviously make sure you use the appropriate username here. And the password was capital P A55W0RD exclamation mark. Again, if you used a different password, make sure you enter the correct password here. Then I'm going to hit login, and that will redirect me back to the web application. And you can see there I've sent a request to the API and got back the weather forecast data from that authenticated endpoint in our API. So that is essentially a web application up and running using OpenID Connect, going off to IdentityServer to sign the user in interactively, coming back with an access token, and then using that access token to send an authenticated request to our API project. So what we are going to do now is create a single page application. So what we are going to do is right click the solution, add a new project, and we're going to select ASP.NET Core Web Application, and we are going to select a Blazor WebAssembly app. Blazor WebAssembly being a single page application framework. And I'm going to call this single page application, like so. As I say, Blazor WebAssembly. Authentication we will set to individual authentication, because that will set up the application with the various authentication components that we can make use of. And I will enable Linux Docker support for this project. So once that's all done, hit create, and that will create us our Blazor single page application project, which we can see here over on the left hand side. So here we have our boilerplate file new Blazor web application. And what we're going to want to do is first of all configure the authentication for this application. So what we'll do is we'll open up the program file, and you can see here that we have builder.services.add_OIDC, that's the abbreviation for OpenID Connect, authentication, with our options. Now this by default is set up to bind to a key local in app settings. What we're going to do is override that. First of all, we will change the options, so it's remote authentication options to make it clear. Then we'll say remote authentication options dot provider options dot authority equals builder.configuration. And this will be exactly the same as we've done in our other projects, authentication:authority. Next up, we will say remote authentication options provider options client ID equals builder configuration, and this will be authentication:client ID. Next up, we are going to do remote authentication options, .provider options, .response type. And this is going to be code, because this will use the auth code with Pixie Flow to authenticate the user. And then last but not least, we will set up the API scope. So we'll say remote authentication options, .provider options, .default scopes, .add, https www.example.com/API. And that will be our API scope. So that is OpenID Connect authentication up and running, configured. What we're going to want to do though is update the app settings. Now you'll recall in our other server-side applications, we've simply used environment variables. However, this is of course a single page application, which means it's running client-side in the browser. That means that environment variables in the Docker Compose file won't be picked up because the application will be running on the client side as opposed to the server side. And so we need to configure those details in the app settings.json, which is located under www.root and app settings.json and app settings.development.json. If we come into app settings.json, we can see here we can replace local with authentication. The authority, we can replace that with our IdentityServer URL. So that will be IdentityServer and then port 7000. The client ID, if we go into the database, open up the clients table, we can pull out the client ID for our single page application, fill that in for the client ID for the authentication. And what we are going to do is copy that and paste it into the development app settings. Of course, when you come to running this in production, you'll update the app settings.json itself with the production values when you deploy the app to production. But for now, we keep it the same with our IdentityServer URL from within the Docker container. So those are our app settings updated in the single page application. And now what we're going to want to do is enable us to send an authenticated HTTP request with the access token that we get back from IdentityServer. So what we are going to want to do for that is to add a custom authorization message handler. Now essentially the authorization message handler is provided out of the box by Blazor, but at the time of recording, that message handler will only attach access tokens to HTTP requests that are being sent to the same base address as the Blazor application is hosted on. Of course, that's no good for us because our API is running on a different URL to the Blazor single page application. So what we need to do is create a custom authorization message handler specifically for our API. So what I'm going to do is create a new directory called handlers, and inside this directory I'm going to create a new class called API authorization message handler, like so. And this is going to extend the authorization message handler provided by the ASP.NET Core WebAssembly components. You can see here we can generate the constructor, which takes in an access token provider and the navigation manager. And inside this constructor, we are going to call the configure handler method. And this takes in a list of authorized URLs. That's a list of essentially API URLs and a list of scopes that should be in access tokens passed to that API. So what we're going to do is new up a list with our API URL. So that's going to be https://API port 7001. And we're going to then new up a list with our API scope. https://www.example.com/API. And that essentially will mean that with this message handler in place, any requests that are sent to API port 7001 will have an access token with the API scope inserted into the authorization header and sent along with that HTTP request. So what we can now do is add this authorization message handler into our startup. So what we can do is we can say builder.services.add_scoped API authorization message handler. And what we're then going to want to do is set up an HTTP client that uses this message handler. You'll notice that out of the box we have this default HTTP client which uses a base address of the Blazor URL. We don't want that, we want a custom HTTP client with a base address of our API. So in order to do that, what we are going to want to do is come over here to a NuGet, go to our single page application, and we are going to want the Microsoft Extensions HTTP package. This package just here, install that into our single page application project. And this will allow us to use the HTTP client factory and other HTTP client based components in our Blazor WebAssembly application. So what I'll do is I will get rid of this services add scopes, and I'm going to say add HTTP client. I'm going to give it a name of API since this will be an HTTP client for our API. And then what I'm going to do, use the callback here, and then I'm going to customize this HTTP client. I'll rename that to HTTP client like so. And then in here, I am going to say HTTP client dot base address equals https://API port 7001. That is the base address for our API. And I will wrap that up in a URI like so. That is the base address configured. And then what I'm also going to do is add an HTTP message handler. And this will be our API authorization message handler, which means that any request sent using this API HTTP client will automatically invoke this API authorization message handler as part of the request pipeline. So what I am going to do now is open up the pages folder, and you'll notice here we have a fetch data page. And so what I'm going to do is replace this injected HTTP client with the HTTP client factory. So I'll do that like so. And then if we scroll down, we have our onInitialized async method. And this is where we set up the logic that we want to run when the component is initialized by Blazor. So what I'm going to do is I'm going to say await and then HTTP client factory dot create client. I'm going to specify the name here of API, and this essentially means that the API HTTP client will be used. And this then get from JSON async, we can replace sample data and weather.json to just be slash and then weather forecast like so. And that will be the weather forecast in our API that we created earlier. What I'm going to do, last but not least, back up at the top, I am going to require the user to be authorized to access this page. And so I am going to say @attribute, and then I'm going to add the authorize attribute to this page. And that will mean that the user is prompted to sign in if they're not already before this page is rendered. So now that we have that page added, we can now flip back to our Docker Compose file and add the single page application into Docker Compose. So what we do is show all files, pop down to here, open up our Docker Compose. I'm going to copy the web application like so, and I will paste it in just above, and this will be called single page application like so. The Docker file is going to be single page application /Docker file, and This will depend on both the API and the identity server. You'll notice the entry point though, we don't need this entry point, and that's because we won't need to update the trusted certification authorities for this Docker container. The beauty of the application running client-side is that it will rely on my local machine trusting the certificate, because it will be my local machine making the network request and not the Docker container making the HTTP request. So we can get rid of that entry point, and as I mentioned earlier, the environment variables, that data is stored where appropriate in the app settings, and the rest of the environment variables are redundant because this is client-side, not server-side. The ports, however, we will keep, and we will use the next logical port, which is 7003. Because we got rid of the Kestrel configuration, we can also get rid of the PFX file, and we can also get rid of the localhost.crt volume mount, because we are not updating those certificate authorities within the container. That's all handled on the local machine because the application is running client-side. So what we're going to do now is we are going to modify the Docker file for the single page application. Now that's because by default this is set up to run single page application.dll, which of course is fine for a back-end server-side web application, but we won't have a DLL because this is just going to be a single page application with a JavaScript. So what we will do first of all is update the base image from ASP.NET to Nginx. I'm going to use Nginx here as just a static file web server. Feel free to use any other static file supporting web server that you deem appropriate. The work directory I'm going to change to be user share Nginx HTML. That's the default HTML folder for Nginx for the serving of those static files. If I then come down to the bottom, we can say from base as final. We can update the work directory to match the work directory above. And copy from publish, we are going to want to copy the www root folder, because that folder will contain our published single page application source files. So we'll copy those source files from the www root folder on our local file system into that Nginx HTML folder of the Docker container, of the Docker image, sorry. And we can then get rid of the entry point because Nginx will simply be running in the background for us. So that is our Docker file updated. And because I'm using Nginx, I just need to add a configuration file for Nginx. So to do that, I'm going to create a file called a default.conf in the root directory of the solution. And inside here, we're going to create a server block like so. Inside the server block, I'm going to specify the server to listen on port 7003. That was the port that we opened up in the Docker Compose port configuration. The server name is just going to be a localhost, like so. The location is then going to be just a root. And inside here, we're going to specify the directory as user, and then share, Nginx, and HTML. You'll recall that is where we copied the static assets when they were published. We copied them into that Nginx HTML folder as part of the Docker image. And then last but not least, we can say try files, and we can say $URI, and then $URI/, and then /index.html. That's the common single page application try files configuration for running in Nginx. Stick a semicolon at the end of those lines, and then what we can do last but not least is mount that default.conf file from our local file system into the Nginx Docker container. So we're going to create a volume mount, much the same as we've done elsewhere, and we're going to say default conf, and that's going to be mounted to etc Nginx, and then conf.d docker/default.conf. And much like the others, that will be read-only because we don't need the Docker container to be modifying that file. So we can simply set that to be a read-only volume mount. So that is our Docker Compose file updated for our single page application. And so what we're going to do now is run that Docker Compose deployment, and that will now build all of our applications, including our new single page application, and then it will create containers for each of those Docker images. So I'll give that a few seconds. As I say, it's going to be pulling down the Nginx image for the first time, so it will take a few seconds longer the first time you run it, but then subsequent runs will be much quicker. As you can see, it's just building the last few image layers now, 62 out of 66. And there we go, running 6 out of 6. So if we expand those Docker Compose services, we have all of our applications up and running. And if I now go to the browser, and if I go to HTTP, and then single page application, running on port 7003, like so, you'll notice here we have our single page application. And you'll notice in the top right hand corner, I am already signed in. That's because I was previously signed into the web application, and that is one of the beauties of single sign-on. Because I'm already signed into the identity server, when the single page application is loaded up, it's checked to see if I'm signed in. It's found that I am signed in already, and so it's signed me in straight away into the single page application. What I will do is I will hit logout, and then you can see I can click here to return to the single page application. That will then bounce me back. You can see I am now logged out. Back on the home page, you can see I'm no longer logged in. So what we'll do is we will go to the fetch data page, and that's now triggered an authentication request to IdentityServer. I'm now going to log in again with the username thomas.clark. Again, feel free to use whatever username you chose when you created that user. The password, PA55W0RD, exclamation mark. Again, if you used a different password, make sure you update it appropriately there. And then if I hit login, you'll see I'm then taken back to the single page application, and you can see I have fetched API data from our API using that access token that we got back from the identity server. So that shows you essentially how you can authenticate a wide variety of different applications. So as you can see here in our Docker Compose file, we've got our API, we've got our console application, we've got our database, we've got our identity server, our single page application, and our web application. So really this shows you how you can create a complete solution with an identity server forming the core, if you like, with an API that accepts authenticated requests, and then a bunch of applications of different types, console, web, and single page, that go off to identity server, get an access token, and then use that access token to send authenticated requests to the API. As I say, I hope you found this video very useful, and thank you very much for watching.